The residential sector consumes around 25% of total energy in Chicago, and 60% are for heating of space and water, mostly due to the cold and windy climate in Chicago. Our aim is to create a sustainable solar energy harvesting system that requires low maintenance, is cost-effective, energy efficient, and eco-friendly. We plan to provide middle-class households in Chicago with an alternative solution for supplying electricity and space and water heating. Sustainability comes out as a key term in our project, and we have defined it as an energy source from non-exhaustible resources which will support current citizens as well as future generations. Throughout our project, we have used the following criteria as guidelines. Number 1. Viability. It has to be more viable than wind energy. Number 2. Efficiency. Maximum production for minimum waste. Number 3. Cost effectiveness, to reduce household bills. Number 4. Longevity. Long-lasting design which is easy to maintain. Number 5. Accessibility. Affordable for stakeholders. For our solution, the stakeholders were the middle-class citizens in Chicago. Through our research, we found that we would need roughly 10,000 kilowatt hours to provide heating and electricity for a whole year to a single household. To cover these amounts of energy, we would need 30 meters squared of monocrystalline solar panels for electricity and 50 meters squared of evacuated tubing for heating. For the decision-making process, we made a pairwise comparison to prioritize the most important aspects using the Access FM anagram. The components with the higher team votes were given a higher preference. We took the following criteria into consideration. Aesthetics. It should look great to increase its external appeal. Cost. It should be cost effective to get some incentive for the customer to buy. Customer. It should suit the customer's needs. Environment. It should be environmentally friendly in the long run. Size. It shouldn't take up too much space. Safety. It shouldn't compromise with any of our safety measures. And materials. It should be made of a readily available material that is also eco-friendly. We combined our best ideas after having no single standout design idea. From this, we gained our final solution. Our team's final solution for a solar energy harvesting system is a combination of angled monocrystalline solar panels to provide clean electrical energy to the household and solar evacuated tube collectors to be used for space heating. For each household, we are looking to cover approximately 15 meters squared of roof with evacuated tubing and 35 meters squared with monocrystalline solar panels. In addition, each household will have their walls, roofs, doors, and windows appropriately insulated if it's not already done. This combined solution, estimating from our energy model, will more than meet the energy demand during the summer seasons and will hopefully meet most, if not all, of the electricity demand as well as 60% of the demand for space heating during the winter season. The household will still be connected to the main grid to feed the extra electricity in during the summer and used as an additional source to meet energy demand during the winter. Our final solution provides energy to the people of Chicago using a non-exhaustible resource in light from the sun. The system itself is proven to be long-lasting and will support the residents of Chicago for years to come with little to no maintenance, proving our solution meets our definition of sustainability. Being sustainable wasn't our only goal within the project. We aimed to meet our criteria and brief, whilst also ensuring the design was technically feasible, economically viable, and socially/environmentally desirable. Our final solution has met these goals using tried and tested methods that have been proven to work. It will provide clean energy to the people of Chicago at an affordable price, roughly $20,000. Over time, the solution will make the residents money, showing its economic viability and why it is highly desirable. Our solution has proven to be more viable than wind by providing more energy per dollar per year than the typical wind turbine in both summer and winter. It is cost effective by providing the necessary energy for a relatively small price while retaining its longevity and still being accessible to the people of Chicago. For these reasons, our solution does solve the energy need for our stakeholders.